Hello everyone and welcome back to my 3D platformer tutorial series in Unreal Engine 5. In this episode we'll be going over the advanced locomotion that we'll be adding to your project. This is what we're going to add. So we're going to add a crouch and all the animation that goes with it. We're going to add double jump with animations. We're going to add the wall slide functionality and then the wall jump. So this all combined together will allow you to do something like that. Single jump into jump off the wall into dash, giving us all this nice flexibility of movement, and then we can go straight back into all of that. So let me show you how easy it is to implement all of this, and let's get it into your project. So starting off, we're going to need some animations. So I recommend going and downloading the Lyra project from the Unreal Engine Marketplace. It's completely free. It comes with a bunch of great animations that we're going to use in our own project. So once you've downloaded the project, open it up, and what you want to do is you want to come to characters, heroes, mannequins, animations, unarmed, well, locomotion unarmed. And we're going to grab a couple animations. So the first one is going to be this unarmed jog forward stop. And then we're going to scroll all the way down to the crouched idle. We're going to have the crouch walk backwards, crouch walk forwards, crouch walk left, crouch walk right. And probably just to be sure, be safe, this crouch walk forward stop. Okay, so once you have all of these selected, right click, go to asset actions. We're gonna export. You could migrate them across to your project, but that will bring the dependencies with, which I don't really want, as it will make our original files cluttered with things we don't necessarily need and can be confusing. So let's just export, and we're going to export them to a animations folder. So go to wherever your project is and just create a folder called animations, and then just save each animation into here. As you can see, I've already done this for all the animations I'm using, but just go ahead and you'll probably have to do them one at a time. So on the FBX export, probably just make this 2020. You can leave everything default and just click export and do the same for the rest of everything. Okay, so once you've done with that, you can close out of the Lyra project and go back to your own project. Okay, so now that we've got our animations out of the Lyra project, what we're going to do is come to our content browser, right click, create a new folder and label it animations like I have here. And in here, I've just moved our animation blueprints and the dashing montage into this folder. Yours will probably be under third person blueprints or under characters here. I just moved it here just to have everything centralized. You can do the same, but it doesn't really matter. So what we're going to do is we're going to right click anywhere here and go import to current folder, and we're just going to select all of our animations. So just get all the ones I want. There we go. And we're going to open them up, and what you want to do is you want to scroll down until you get to the skeleton section, and you just want to make sure that this is the SK mannequin, and you can leave the rest default. So import all of that and then just save all. So what we want to do is we want to select everything here, right click, go asset actions, and change this, well, select this edit selection property matrix, right? So now we can change all the properties of these in one go rather than having to do it individually. So come to the, under root motion on the right side, and enable root motion and force root lock on all of these. Okay, then just click compile, save, and all, as you can see in the middle here, all of these have been updated to have root motion and the force root lock. So what root motion is the animation drives where your character goes. So for example, if we had a slide, if we animated it in Blender or other software, we would make the character slide a certain distance in the software, and then that animation, when we bring it into Unreal, would drive how far we move the character, rather than having to input values like, let's say 20, we're going to move the character 5 meters every time he slides. We let the animation do that rather. So that's basically what Root Motion does. So what we're going to do is we're going to come to our BP player and go to your crouch section, and just make sure that yours is set up like mine, like we set up I think in the first video, just to have this crouch and uncrouch functionality. If not, just get your input action crouched, get a flip-flop off the started, and basically what the flip-flop is when you press it once it does A, and when you press it again it does B. So on A we're going to make the character crouch, and on B we'll make them uncrouch. And I just have you have some print strings to show that we are crouching. Okay, so let's set up the animations to actually see our character crouch. So open up your content browser, go to your animations folder, right click and go to animations and create a blend space. And make sure you select your SK mannequin, and we're just going to put your BS for blend space, and we're going to put your crouch locomotion. Okay, open that up, and then on the left side yours might be collapsed like this, but you want to open up your horizontal and your vertical axis, and we're just going to label this direction, and on the vertical axis speed. So direction is which way our character is facing, and speed is obviously how fast our character is going. So for the minimum value put -180, and for the maximum value 80. Grid divisions 4 is fine, snap to grid on, and then speed we're going to put 0, and here we're going to put our max crouch speed. So to get that, go back to your player character, select the character movement, and under your character movement walking, here is this max walk speed crouch, which is 250. So that's what we're going to put here, 250, and snap to grid. So once you've done that, in this graph here is where we're going to put our animations. So I'm just going to search for idle, and here's this unarmed idle crouch. We're going to put it here and see our character starts crouching. Now I'm just going to put it at every section here, so that no matter which way we're facing, this is the idle animation. Okay. So next what we're going to do is we're going to get the walk forward, which I think is labeled like that, unarmed crouch walk forward. There we go. And we're going to snap it all the way to the top. So if we had control on the graph here, we can see what happens to our character as we move along the graph. So from idle to walk forward. Okay. So what we're going to do next is we're going to get the backward, and we're going to put this on the edges. So basically if our character is walking backwards, that's not the crouch walk, just drag the crouch walk over. So you see our character will always be walking backwards if we're going 180 degrees, which is behind us. So next we're going to get the left. Here we go. And we're going to put that on the left side of the graph. And then we're going to get the right and put that on the right side of the graph. So character's walking forward, walks to the right, then walks to the left, and walks backwards. So you can see how we blend between all of them, and it gives us a nice smooth motion. Okay, so once that's done, click save, and let's implement it. So what you want to do is you want to open up your animation blueprint. If you don't have it, what you want to do is you want to go to your BP player, go to your viewport, select your character, and here under anim class is this ABP many platforming. So click this little folder with the icon and it'll take you straight to it. So open it up. We're going to do a couple things. So I'm not sure because I was testing, but there might be already a crouch locomotion for you here. And if not, I'll show you how to create one. So right click here and go state machine spell, and we're going to tap this out as crouch locomotion. Okay. And just a quick thing, we're going to be referencing cache poses, which is basically just sort of like a reference to our original state machine. So just drag out of the little man here and type cache and new save cached pose, and just label this the same, crouch locomotion. Okay. So that's fine for now. Click compile and save, and you'll see you'll get a bunch of warnings. Don't worry about this. It just means we haven't put anything in the crouch locomotion. Okay. So let's go into our state machine, and we're going to put here add state, put crouched locomotion. Once we're here, we're going to go into our crouch locomotion, and we're just going to look for that blend space we created. So blend space crouch locomotion, and connect that up here. And then we're just going to go to this essential movement data that came with the project and get this ground speed and just connect it there. So click compile and save, and your errors should now go away. So now we need to go add it to our main state to say when we can transition between normal locomotion and crouch locomotion. So go into your main state, come down here to this locomotion, and we're just going to right click on the graph and say add state. We're going to say crouch locomotion. And from here, we're just going to drag out the cache pose of crouch locomotion, or cache pose, sorry. There we go. And now we're going to transition between the two. So drag off from this little orange block around the locomotion label up into here, and then do the same for back. So basically we're gonna be able to transition from locomotion to crouched and from crouched to locomotion. So now we need to set a variable to allow us to go there. So to do that, open up your event graph, and if it's not here on the left side, you can double click on this event graph and it will take you here. So what you want to do is you want to come off the sequence, add a pin like it is here for 5, and we're just gonna come add a reroute node down here, reroute node, just to make it a bit cleaner. Then we're gonna come to get our reference to our character under the references here, get that, and then we're gonna check is our character crouching. Get is crouched. You'll know it's the right one because it's got these two little spheres, which comes as part of Unreal Engine. So once that is set, we can drag off here and promote to variable and label it is crouched. I already have one, so I'm just going to drag out and set this like this. Yeah. So now this is telling the animation blueprint when we are crouching. Okay. And just label this set crouch state and compile and save. Okay, so you get these errors that's telling you can't enter because it doesn't know why it can't enter. So let's go click on it, and it basically takes you to the main state into these little transition rules. That's the word, transition rules. So just double click on one of them. You're going to first go to our one that allows us to go from locomotion to crouch. So we're going to get our crouching variable. And if we are crouched, we can go through. So not a problem. So go back and then go to the transition from crouch to locomotion. And we're going to do the opposite. So get is crouched and go not all. So if we're not crouched, then we can go back to normal locomotion. So let's see if that works. So here we are, and I'm just going to press my crouch button, which I have set as C, and our character is now crouched and walking at the appropriate speed. Now you might not see the animations for when we're walking left and right, but that is because we haven't set up the camera to follow a specific target. So if we had, say, a lock-on system and our character was to strafe around them, we would then see that animation. But for now, this is fine. And if I press C again, I'm back to normal. Okay. So that's it for the crouching. Let's move on to the next one. Okay, so now on to the double jump. So I showed you, I think in the first or second video, about how we can implement the double jump functionality right in our character movement. So let's do that now. Okay, editing chain here. So on the part on the double jumps, I originally said go to your character movement, and under the max jump apex attempts is where you'll add your double jumps. That's not correct. What you want to do is you want to go to your BP player up here instead. You'll see if you type in jump in the details panel, you will come down to this jump max count here, and this is where you'll change the jump amount. The jump max hold time is how long you want before your character reaches the apex, which I think I covered originally. But yeah, this is it, not the max jump apex attempts. It's this one here, the max count. Okay. So here's all the values you can change. This is just what I have. This is nice and easy. So I told you that in the previous video, what we could have done is just drag off our jump button, our jump input action, and just type jump, right? And then that would allow us to double jump. But what we want is slightly more advanced. So just reconnect your try multi-jump, and I'll show you how we can get that working with the multi-jump. That includes the wall jumping, which was already part of our project. So let me show you what that is. Here is on our advanced jump function. So let me just explain what each one does. So this basically, if we're dashing, we can't jump, right? So that's basically what this check is. And if it is, we're then going to check if we're grounded. And if we are grounded, we're then going to jump once. Nice and easy, right? And this activate trails is just those free trails you see when your character jumps. But if we are in the air, we're going to check then if we're going to double jump. And if we are going to double jump, we got to check if we're jumping off against the wall or not. So that's what these two checks are. So this checks if we have jumped against the wall, and this checks if we haven't. Okay. So then this is all just the collision sphere trace that checks that our character is jumping against the wall. It basically shoots out a sphere in front of the character, which is this wall jump distance, which has a default value of 50. So 50 units in 50 unreal units in front of the character. And then it just checks the results to make sure that it can, and then rotates our character the opposite direction of the jump normal. So the jump normal is basically whichever way our character is facing against the wall, it's gonna turn our character 180 degrees and jump them the opposite direction. And then it's gonna launch the character off the wall, activate those trails, and then just set a delay until that we have wall jumped, so we can't infinitely wall jump in that exact like same frame or like one frame. So this delay between frames is 0.1 of a second. So that's how long it's going to be before it allows us to wall jump again. So that's just the basic explanation there. But what we're going to do is come down to here where we're not checking if we've jumped off the wall. And then it checks if we've double jumped, which is great. And then jumps, right? So all we're going to do is we're going to change this a slight bit to incorporate our double jump with animations. So drag all of this over to the right. And we're going to create a new variable, which I think I've already added it here. Okay, I think this is actually a variable that's part of the engine itself. So just right click and go jump current count, get jump current count. Yeah. So this variable just tracks how many times we've jumped, right? And from here, we're going to go switch on int and add 2 pins. So basically, this is going to count how many times we've jumped, right? So when we jump once, it will go here. And when we press the space again, we'll jump here, right? So all we want to do is copy this to here, add it to the 1. And then we're going to drag out from our mesh and go play montage, right? And if you have a unique montage, you could just put it here, but we're just going to use the jump montage. And then we're just going to copy the trails if you want them, and we'll put them to here. Okay. So this is the double jump with animation. So if we had, let's say, a Mario jump, then we could do this. If we wanted to have a third jump, you would obviously come into your character movement panel, add jump and put this to 3, and then you just add a third pin here. But we don't need that, so I'm just going to remove that execution pin. And that is the simple double jump with animation. So let's check if it works. Compile and save. There we go, nice and easy. Okay, next we are going to work on the wall slide functionality. So come into your event graph of your BP player, find some empty space. We're going to need a lot, so this isn't going to work for us. We'll just go over to the side here and just type event tick, because what we're going to do is we're going to constantly check if we're against the wall or not. So from here, just to make life a bit easier, because there's going to be 2 functions that we're going to run off the event tick. Let's just add a sequence and I'll show you what we're going to do for the wall slide. So what we're going to have to do is we're going to have to check if our character is falling, and if they are, then we run the trace. And we also need to make sure that they are falling down, not jumping against the wall to go up. So let's add those 2 things right now into a branch. So get a branch and connect it to your first pin. Okay, then get your character movement and check is falling. Yeah, great. Wrong one, is falling. Will be this nav movement one. That's the correct one. Okay. Because we want to check against 2 factors, we add an and boolean, and if you needed more, you could just add more there, but we don't need this, so remove the pin. We only need the one extra. So then we're gonna get our player character, and we're gonna get the velocity, and this just checks if our character is in movement, and we're gonna split the struct pin because we're only interested in the z velocity, which is your up and down. So we're then gonna check if it is less than 0. So that basically means we're falling down. If it's greater than 0, it means we're going up. So just add those like that and add the and pin into there. So let's just move everything over because we want it to be nice and neat. Okay. From there, we're gonna get a capsule trace by channel. And now we need to set the location of we want the capsule trace to happen, and we basically want it to happen from our character. So get actor location and connect it to both the start and the end. Next, what we want to do is we're gonna want to set the capsule's radius, right? So for this, we're basically just gonna copy the values from our capsule component, because we basically want to search that this capsule component is hitting the wall. So click on your capsule component and you'll see we've got the half height and the capsule radius, right? So input the same, but for the radius, we're going to add just 1 more onto there, just so that we can be slightly bigger than our capsule. And then the half height will be exactly the same, of 90, right? So just to make sure it's working, we can get this draw debug type for 1 frame. So when we jump in, we can actually see what's happening. Okay, now we need to check if we are actually against the wall, and if we are, then we'll go ahead with the code. From the out hit, type in break hit result, and this is just going to get all like the values of the capsule trace and its results, right? So what we're going to do is we're going to come here and we're going to create a new variable, call it in wall slide, right? So just hit a new variable in wall slide. And I've just created a new category called Advanced Motion. So all you can do is come up to your category type here and just type in Advanced Motion, and it will auto create the category. So I've already got mine. So just get yours and set it, right? And we're going to set this to as blocking hit. So basically what that is saying is that if we are hitting something, we set the wall slide to true, right? And then from there, we're going to get a branch. And we're just gonna drag in this blocking hit to here to make sure we are blocking. And then we're gonna drag in our character movement because we're gonna set the gravity of the character when we're falling down. So just drag out here, set gravity scale. Oh, not that one. Set gravity scale, this one over here. And to get this gravity scale, we're going to set it really low, but let's just find out what the default is. So go back to your character movement component and just search for gravity here. And you'll see our gravity scale by default is 2.5. So remember that. So we're going to set that to something low like 0.5 or even 1 if you want to. And then we need to do it again if false. So if we aren't wall sliding, then we need to set the gravity back to the default, right? So that's 2.5. And if we are, we just want to make sure that our character isn't in the wall slide, or if we've gotten off the wall slide. So off the false, we're just going to set the wall slide to false, right? And basically that is the simple of it, but we'll run into an error. But for now, let's just comment all of this as the wall slide logic. Okay, compile and save. So let's test that out and I'll show you the error at the same time. So here we are, let's check if it works. So you can see the error there, but if I just jump against the wall, you can see our characters moving slowly down. So you can see here our gravity is really bad. So that is actually a problem, so let's fix that. Okay, so I think I found what the problem was for why the character was getting this gravity really low. So let me show you. So if we do that and then we jump here, you can see our gravity is really low, right? So basically what's happening is it's never checking for a false value. So it's not doing anything to change the gravity. It's essentially saying that we're always going to be at 0.5 after we've touched the wall, which is not great. And then eventually it will fix itself. But also we've got this problem where we're sliding against the wall and we jump and the gravity is really high. So let's fix that now. So coming back into your player blueprint and this gravity scale, we're just going to drag off this branch here to check if we are hitting anything and just set this into the execution pin of the false to set the gravity back to normal. Okay, that's the first fix. And the second is actually at our jump functionality. So come over here to your jump and we're just going to do the same thing here. Is we're going to set the gravity scale to the original value of 2.5, which is our default, and compile and save. So anytime we try and jump, it's going to set the gravity back to the original default value. So let's test it out. Okay, here's the double jump at normal gravity. Great. It's wall slide, jump, gravity is fine. And if I double jump against here, you can see we slide down slowly. You can even set it low if you want. But when we jump off the wall, our gravity is normalized. Okay, editing Shane here. I forgot to show you the wall slide animation so that when we are wall sliding, our character's animation changes, right? So let me show you what I did to get there. So if you come into your animation blueprint to the main graph, you go to your main state machine, and then to the fall and jump loop, right? So from jump, we're going to be able to wall slide, and then while falling, we also want to be wall slide. So right click and go add state and just call it wall slide. Okay, so now that we've done that, you just want to drag out the pins to there and same to there and then back down, right? So come into here and then just set whatever animation you want. I just chose the pistol one as it's easily seeable that we're wall sliding because the animation changes, right? So we need to then set the variables that allow us to do this. So go to your event graph all the way down to where we set the is crouch, right? And we're just going to drag out of here from our character reference and get is wall is sliding. I think it's in wall slide, right? And then we're just gonna right click and promote to variable and call it in wall slide. I've already got the variable, but yours won't be there, so just add that. Yep. So mine is under Advanced Locomotion, which I showed you how to make earlier, and I set this, and then I'll just comment it. Just say set wall slide, right? Compile, save. So you can see we've got the jump to wall slide, which can't enter transition. So all we want to do is, okay, let me just get rid of all of this, show you from the beginning. Just drag into here, drag into there, right? So from jump, we want to go check if we are wall sliding, and if we are, happy, go back, do the same here, and then go back, and we're just going to say this is not bool, so that we're not against the wall, and add it there, right? So compile and save, and let me show you that quickly in the engine. Yeah, so you can see our character's arms move to that pistol position because we're wall sliding, and then when we land, back. So yours might not reset the reset to the animation. You might just end up T-posing or staying in the last known animation, right? So to quickly fix that, go back to your animation blueprint in your main states and this to land functionality here, right? All you want to do is you want to come to this state alias and just check wall slide on. And once you've done that, your character will then transition back to the original landing state. So if I turn this off, compile and save, I'll show you quickly. So there we go. And then our character's stuck in animation, which obviously we don't want because it looks terrible. And then back to normal. But just to fix that, go back into your animation blueprint and just double check that this wall slide is ticked on. So that's the double jump. Sorry, the wall slide. Okay, so let me show you the final bit of movement, which is to make our character run faster over time. Similar to how Mario does it in Mario Odyssey, that the longer you hold down the button, the faster your character will go to a certain point. So let's get into that now. So what you want to do is you want to come over to your event graph, and we're going to create a couple variables first. So we're going to create this is sprinting, which is a Boolean, the base walk speed, which is a float, max sprint or walk speed, which is a float, the run acceleration time. This will be how long we want our character to reach the maximum speed. So for default, I've got it to 2 seconds here, but in your actual game, you might want it something like 5 seconds or longer or shorter, depending on however much you want. And the current runtime is basically going to be a counter for how long it takes to reach the run acceleration time. And your max sprint speed will be the value you want your character to reach eventually. Okay, so then come over to your event tick, and we're going to go off the second execution pin. So we need to do a lot of checks, and this will make sense as we go over time. We need to make sure that our character is not at 0 to make the animations look weird. We need to make sure they are actually moving over time. So let me go over the logic with you, and hopefully it will make sense as we go through it. So first we want to get a branch, right? So put a branch down here by holding B and connecting the pin, right? So this is going to be our first check. Basically, we're going to check if our character has moved. Or it has moved from the last input and is still moving. So to do that, just right click on your event graph and type get last movement input vector. Yeah. And we're going to get the vector length. This is just checking if this value is, if there is a value and what is the value. And we're going to check if this value is greater than 0.1. So it's just checking that if we are moving at all and not at idle. And it also stops if the idle animation has any sort of slight movement to it. So check that up to your first branch. And I'm just going to neaten this a bit. There we go. Okay, I'm just going to neaten this pin as well. I'm just going to double click on the line to get a rewrite node. And there we go. Come. So from there, we're going to get another branch. And we're going to drag off the true. And here we're gonna get the velocity of the character. Oops, good spell. Get the vector length. And this is just going to check if we're coming to a stop. So just make sure that this is greater than, let's say, 10. 10 is a good value for me. And this is just making sure that we're slowing down, right? So just connect that all like that. We can now move it a bit closer. And then we're going to go from here to do another branch to check that our character is actually sprinting, right? So what we need to do then, just hit compile and save, is actually go over to our movement input, which is over here. And after the move action, we're going to just add this is sprinting function boolean and set it to true if we are moving. And off the cancel and completion pin, we're going to set it to false to say our character isn't running. Okay, so that's basically just how easy that is. I hope that makes sense. Okay, so go back to your code now, and we're going to just check the value is sprinting against the condition, right? So what we're going to do then is we're going to drag off the true, and we're going to set the current runtime, right? So like that. And our current runtime is going to be current runtime plus to add, and we're going to come all the way back to here to get this delta seconds, and we're going to plug that into there. So just rewrite this to make it a bit neater. That maybe down here, add some more reroute nodes. Okay, and that's basically every time the game ticks, or every second, it's going to add to our current timer, right? But we don't ever want it to go over the max timer. So what we're going to do is just clamp this. We're going to get a clamp float, right? And this max value is going to be our run acceleration time. So basically every second we're going to add to this until we reach this run acceleration time. So if this was 5 seconds, it would go 5 seconds until we reach the max acceleration time. And then we're just going to set this into the current run time. Okay. Okay. From here, we're then going to get our character movement and set the max walk speed. Okay. This one, and just connect up the pins. So what we're going to do now is we're going to make it happen over time that our character gets faster and faster. So from this set current time, we're going to drag out here and we're going to divide it by our run acceleration time to get a sort of percentage of what we need. And then from here, we're going to loop it and just hold control and drag from your A pin to alpha. So this is basically the percentage of 0 to 1, and over time it will go between A and B. So 0 being, A being 0 and B being 1. So we're going to get our base walk speed and drag it in here, and max walk speed. So just to set these values initially, I just set them to what the base game's walk speed is. So if you come over to your character movement, just look here for max walk speed, which is 600. So the base walk speed is 600, right? And then the max walk speed is going to be how fast we want the character to go. So 900 is what I've set here. But if we set it up to something ridiculous, like 1500, you'll see our character will go really fast. So just return that value into our max walk speed. And that's all we need to do for increasing the speed. Now we definitely need to decrease the speed. So I'm just going to move all of this over slightly, because we need to drag off the false pin here. So we're going to basically do the same thing, but instead we're going to be slowing down over time, right? So we're going to drag out here and set our current runtime. And we can drag off the world delta seconds, which is here. But for now, we're going to get our current runtime. And we're going to subtract. And we're going to subtract the world delta seconds, right? So let's just move this up a bit, so we have a bit of a neater bit of code. We could also just double click to reroute the nodes here to make it all look a bit better. Okay, so then we need to clamp this, float, this one here. And again, nope, that's actually fine. Leave the value there, but the run acceleration time is going to be the max, so that we're never going beyond it, right? And we have the default as 0 because we never want to go under 0 seconds. Okay, so then we're gonna set the timer like we have here, and then we're gonna set the max walk speed again. So get your character movement, set max walk speed. Okay, drag that into there, and then we're gonna get to base walk speed, and that's our target. So let me go over the logic so it makes sense, right? This isn't the end. We do need to make one thing to the animation blueprint, and that will make it look better. Otherwise, our character will slide across the floor. So from our sequence here, we drag out. We're going to check that our character has received a last input, and if basically the person's let go, then it checks to see if we're still moving. If we are still moving, we are then gonna get the velocity of our character and just make sure that we're slowing down under a 10, or if our movement is greater or less than 10, essentially, just so that if there is any idle animation, we're not moving slightly, right? So then we're gonna check if our character is sprinting, which is the variable we set in the movement. So basically, if our character is moving, we're sprinting. That's essentially the logic. And if we've cancelled or completed, meaning we've let go, then we're not sprinting. Now, from there, we're going to get the world delta seconds, or get the delta seconds, and over time, we're going to increase the runtime. So it'll go from 0 to the max runtime, which is 2 seconds for us, and set the current runtime. And then we're going to take that current runtime divided by our max runtime, so that we can blend between our base walk speed and our max walk speed. And then we're going to just set the value. And we'll do the opposite here, is we'll go off the false. So if we aren't sprinting, over time we will slow down, doing the same thing. So current runtime minus the world delta seconds, clamped by our run acceleration and 0, because we never want to go into negative seconds. And then we set the current runtime. And then we just set the max walk speed to be our base walk speed, which is 600, which we got from here. So click compile and save. And let me show you what that's like. So remember, I set the value to be this ridiculously high value. So our character will run really fast now. So let's see. Over 2 seconds, we should get much faster. And you can see there, our character is now moving ridiculously fast. And as we slow down, there we go. So obviously, if this is what you want, you need to keep that in mind, but you can see our character is sliding, which we don't want. Okay. I'm going to set the variable back down to something realistic, which is, for me, 900. Okay. So to fix the sliding animation when our character speeds up, we're going to come into our animation blueprint, into your main states, into your locomotion state machine, and we're just going to drag or right click and create a new state. I'm going to call this walk stop, right? So we want this animation to play when our character is coming to a stop. So we're just going to click and drag into here, and then from there to there. We can now get rid of the walk to idle, because we don't really want that. We want our character to rather go through this whole loop, right? Obviously, we're going to get errors now, so let's go ahead and create the next variable, which is to set the sprinting, right? So drag out from your character, go back to your event graph, drag out from your character component, and go is sprinting, and get is sprinting, and then just set the variable or promote to variable and set it as is sprinting, right? So set sprint. Okay, so come back to your walk stop, go in here, and we're going to add the animation, which we got from the Lyra, which will be this jog forward stop. We're just going to drag this in here and connect it up, right? So one of the changes we're going to make, and this was a bit of fiddling and faffing, but I'll explain it as we go along, but we need to make sure that this animation syncs up as we go. Because if we open up this animation, you see our character walks forward, even though we've set the root motion to be correct. So you can see here, the root motion, all of that can be correct. Our character will play this whole animation across time, which we don't want. We basically just want, when our character comes to a stop, we're going to basically transition to that. Okay. So let's first set up the logic. Yeah. So we're going to come to this first condition, go into here, and we're going to check that our character's ground speed is less than or equal to 0, and that our sprinting is no longer true. So get is sprinting, and we're just gonna go not bool and make an and variable, an and boolean, and add these two together like that, right? So this is just checking that our movement speed is 0 and that we're not actually moving, right? Or not pressing the movement input. So click compile and save, and then come back to this side, and we're just going to go over to this here and click automatic rule based on sequence. So click compile. Okay. So that's still not going to play the whole thing, right? So let me show you what it does if we play now, right? Over here, and when we stop running, you'll see our character does that, which we don't want. We want it to basically smoothly transition to how we want, right? To how that was in the, like, blending between the two. Okay. So come back to your animation blueprint. And we're going to use a thing called sync markers, right? So go over to your animation. Yeah, forward stop. Oops. Right, and just come under this notify section, add a new track, and we're just going to call this sync markers, right? And basically what we want to do is on this track, wherever our foot lands, we're going to right click, add sync marker, and then just choose the appropriate foot. So this is the right foot that's landing here, then left foot there, to here, which is the right foot again, left foot down. Okay, and then basically look for where our character goes into idle, which is about, let's say here, right? So sync notify and new sync marker. We're just going to call this idle ready. Okay. So what this is doing is it tells the animation blueprint where we want the animations to blend between the two. So now just save the animation and we can close out of it because we don't need it anymore. Okay. So back in your animation blueprint under your locomotion, we're going to go into our walk stop where our animation is, and we're going to change a couple things here to use those markers you've planted, right? So on the right side here, you'll have this sync functionality, right? So what we want to do is we just want to change the group name to something like stopping, and we're going to change this group role to be always leader, and change this method to sync group, and that's it for here. So then we're going to go back here and we're going to click on this transitional rule, and we're going to change this sync group name to validate markers to be stopping. Make sure it's spelled exactly how you set it up here. Let's copy this and go across to here, and then into our idle. So then we're gonna, this will all be defaulted like this. So then we're gonna come in here, place stopping, change this to always follower, and set the method to sync group, right? So click compile and save. You shouldn't get any errors. If you have got errors, just make sure that you've set the group name on each thing to be stopping, and just go back to here on your transitional rule. Just make sure that the sync group name to required value markers is stopping. Make sure that is okay, right? So if we to test it now, we will get this error where our character will still run, right? So you'll see it run. That's because we haven't set it to actually be correct, and that's my fault. So let me show you how to fix it. It's really quick. So go back into your animation blueprint, go to your transitional rule, untick this automatic based on rule, go into your transitional rule, get your ground speed, and just check that it is less than, say, 100. That means our character is slowing down, right? So click compile and save. And now our character should run and slow down appropriately. There we go. So that's how easy it is. And it could show you how, if we go back to our character blueprint and change this run walk speed to say 1200, our character will now speed up to a high value and then slow down. So it looks really nice. And obviously, if you wanted to put different animations in there, you could. This is just the one I used. If you wanted your character to skid, that's all sort of things you can do, but this works for me. Just going to change this back to 900. Okay, so that's going to be it for this tutorial. So in future, if we wanted our character to change animation as they sped up, we're going to create our own blend space using the variables in the animation blueprint, just so we can easily adjust how fast our character wants to go. So if we're going faster than our base walk speed of 600, we will then transition to the nice new animation. But that will be in a future tutorial. For now, this is all for Advanced Locomotion. And just to get rid of the capsule component, let me just show you how to fix that quickly. Go back to your animation blueprint, find the capsule trace, and just set this to none. While we're here, we can set this all to be the increase running speed over time logic. Okay. That's not logic, that is logic, which isn't a word. Okay. What we could do as well is we could right click on everything, highlight everything, and just collapse to nodes, right? And then we can rename this node as the increase run speed over time. And that is that. And then we could do the same for the wall slide. This just allows us to have a much neater event graph. So once we set this up, you can come here. Yeah. And if you go into here, here is just all our input logic. Same with this here. Okay. Show bubble size. Super hard you can see. And then we can move our event graph back. Well, our event tick to where we need. Okay. So that's going to be it for this tutorial. I hope you learned something. If it is a bit confusing, just let me know in the comment section below and I'll try to help as best I can. And until the next one, which I think is going to be that blend space, and as well as the start of our combat. So look forward to that. Anyway, cheers for now.